Hey everybody, welcome to our next video. My name is Rich, this is my daughter Ella, and if you're like us, you're bored out of your mind right now because we're quarantined or everything's closed and there's nothing to do. So we thought, let's have some fun, let's come down to work, let's come down to the shop, and let's just make something. So what we're gonna do today is we're gonna make a queen's chess piece. We're gonna make it out of 3 different pieces. We're gonna use Timascus and Damascus for the materials, and we're gonna call it the Quarantine Queen. I think that's very fitting. We're gonna use this machine that's behind us. It's a Mazak Integrex i200. Now, we're gonna try to get this done in one day, so we're gonna take some shortcuts. We're gonna just try to get this thing done, so it's not gonna be crazy fancy, but I still think it's gonna turn out really, really cool. And I think just because of the situation we're in, I think we'll give this thing away when this is all said and done. So to enter this giveaway, if you're interested in this chess piece, there's only going to be one of them. All you have to do is subscribe to the channel and reply to each of the videos. There's probably going to be more than one video because this is going to be a long process. But anyways, reply to each of the videos, stay positive. Because folks, that's what we got to do right now. Things look bleak. We'll come out of this together. We got to stay positive. So anyways, I hope you enjoy the video. Okay, so here's what we're going to do. I don't want to use the expensive material to prototype on, so we've got this 1.25 inch diameter piece of brass. We're going to cut this. It's a little bit too long, so we're going to cut this and use this to prototype with. Okay, so the first step of this process is to get the material chucked up. And what we're going to do is we're actually going to make the middle piece. So you're going to have 2 end pieces that we're going to make out of Timascus, and the middle piece is going to be made out of Damascus. But the middle piece is the most complicated, so we're going to start with that. So we got the brass chucked up, let's start programming. Okay, so here's the way this is going to work. We're going to make the program. We're on work number 10 here. It's going to be a Mazatrol program. That's what we call it. We're going to do milling and turning. And this is going to be, we're making brass, we're just going to call it stainless steel. The diameter of the material is 1.25, and it doesn't have a hole in the material, so the ID minimum is 0. The length, we're just going to put 5 inches. That's the maximum length that this thing can be. Work face is complicated, we're not going to get into that. This is how it does tool changes. And then this is the max RPM. At any point, it can't exceed that for safety. So we're going to put this thing at 2,000 RPM. And now what we have to do is put in what's called a WPC, and this tells the machine where the material is. Now we don't know where it is, the face of the part's going to be yet, so we're going to leave this blank. I know some of this is going to be hard to follow, but I'm going to do the best I can for you. The next thing we're going to do is we're going to index the head, the B-axis, to the vertical position. So we're going to come here, and we go index 0, 0, 0, and we put the B-axis at 90. We want the B-axis to be vertical for facing this off, okay? So now here comes the actual program of how you do it. We're going to go, it's a turning function, so we're going to go turning, and we're going to go facing, and we're going to do a finish operation. We're going to rough and finish the face, and we're going to leave 2,000ths on the face to finish. And this guy here, we're going to look and see, it's tool number 2. Let's go tool number 5. We're going to use tool number 5, which is a general out 1F. That's how the tool is defined. That's what the machine knows it as. Speed here, we're going to program this for the Damascus. So we're going to go 350. Let's go 250. And 0.004. And we're going to turn the coolant on, which is an M51. And we're not going to worry about the finisher right now. We're going to go 1.25, 0.0500. And then we're going to hit end. And this is the program to face it off. So here's what it does. Okay, so I brought the tool down to exactly where it needs to be in order to face off the end of this bar and clean it up. Okay, so now that we have the tool up to the face of the bar where we want the 0 to be, we have to tell the machine where that is. So we're going to teach it. Right here, you can see the number come up, and now the machine knows where the face of the part is. Okay, so this is going to be the bar out. Now, what a bar out does, you saw the facing. Now we're going to actually turn the OD, okay? So what this is, you have X's and Z's. X is this way, and Z is this way. So here's the numbers. this is what it looks like, okay? So this is 0, 0. This is X up this way. It's just like your coordinate graph in school. So these are all points, dot-to-dot points that I laid out, and I gave the values for each. So if we go back into the program, you can see we do a taper from 0.9 up to 1 inch, okay? So that is from there. Here, let's blow this up. So that's from there to there, if that makes sense. So we do a taper, a linear, a radius, a linear, and then we put radiuses on those corners, a linear with the radius on the corner, linear, taper, linear. That's the way it works. Now, if we look at what the path shape looks like, there's the face, and you can see all the roughing lines. This thing is ready to go. I think it looks pretty good. Let's go ahead and run this section of it. Okay, very cool. Turned out really nice, really happy with it. The next thing we're going to do is we want to mill the notches in the queen's crown here, and we want to do it now before we turn this down because it's more rigid. If we do this after, this can chatter and shake and give us a really bad finish. So what we're going to do is we're going to mill one notch, make sure we like it, then we'll just copy the program and we'll rotate the C-axis maybe 6 or 7 times around to give us those really cool notches. And we're going to use this tool. This is called a ball end mill, and it's designed to mill sideways, and as you can see, there's a full radius on the bottom of it. Okay, so this is the program for the ball end mill. You can see it's an end mill 0.38, so we label it B for ball end mill. And this is a little bit different. When you rotate the B axis vertical, it changes the axis for milling. This is now the x-axis, and this is now the z-axis, and the z-axis gets programmed radially rather than diametrically like we did in Mesotrol. So these are the numbers here. Hopefully this works. You can see where C0, that's the chuck rotation. So we're going to copy this process once we prove this out and go to like C maybe 45, 90, 135, 180, and that will repeat the shape. Hopefully that makes sense. Okay, I'm really liking what I'm seeing. So now what I'm going to do is I'm just going to copy the process and shift the notches around the top of the crown. Now this is what I mentioned earlier, we're going to cut corners. Instead of making all these notches in one separate unit, which would keep the tool right next to the part, we're going to copy them and then it'll go home each time and come back. It's going to take longer to actually run. If I was going to make a bunch of these, I would make it all in one unit, but we just want to make one piece today, so we're good. Let's hope this turns out good. Okay, so looking at it, looks really good. I'm really happy with that. Okay, so the next step is we want to rough out a flat bottom hole, and then we're going to bore this out, putting in some cool radiuses and stuff. But the first step is to get this hole in here. We're going to use a 1/4 inch end mill to do that. If you look on our program, we had to index the B-axis was vertical. Now we have to index it horizontal. And this is the statement here. And what this is tornado milling. So the end mill is going to actually spiral in like a spring, the shape of a spring, get to the bottom, come around, and come out. And that's going to give us that flat bottom hole. Okay, so that went well. We got the flat bottom hole in there, a little bit of chatter, but that's okay. Now we're going to bore it out, and we're going to bore out a hole that's got a little radius, give it a little decoration, and it's going to be a flat bottom hole. I'll show you what that looks like. Here it is right here, and in this bore here, we're going to make a Timascus piece that's going to have like a little pillow top with a little ball on the end of it. So that's what's going to go in there. Let's get that bore done. Okay, it's turning out really well. I hope you guys are enjoying it. This is the good part. We're going to back turn this and get all of the OD done. So we make the B-axis back down vertically now, and we're going to back turn and finish up all of the OD. This is what this is going to look like. So it's going to be this section right here. And I'm a little worried about chatter. When we do the actual one out of Timascus, I will be able to move this farther into the chuck, and that should eliminate a lot of the chatter. But for the brass one, for the prototype, this should be fine. So this is what it's going to look like. Let's get it going. We're getting close now. Okay, so this is why we prototype. Now that I see it in person, I don't like it. It's way too tall. This is going to be the tallest queen that the chess world has ever seen. So we're going to have to flip the bar around, get back to this point, make the appropriate changes. But this is why we prototype, so stay tuned. Okay, and here we have it. So what I did was I made it shorter, starting here. It was way back here before. And then I made this a little bit thicker. I think that looks a lot better. So now what I think we're going to do is let's mill some stuff in here. Kind of make that look a little bit cooler. Okay, we did some fancy milling. I proved it out. It looks fantastic. Now what I have to do is rotate it 8 times. We're starting at C0. So we're going to do a unit copy 19. Shift this to 45. Unit copy 20. 90, unit copy 21, 135, unit copy 22, 180. Unit copy 23. 225. Unit copy 24. 270. Unit copy 25. Oops. 315. All right, let's run it. All right, there it is, everybody. I'm just going to cut it off, and then we'll take a close look at it. Okay, so there we have it. It's cut off. We're going to make the base, and then we're going to make the little pillow top that goes inside of the bore next. So that concludes part 1. I hope you've enjoyed it. We're going to work on part 2 and try to get that uploaded today as well.